Good evening, students. Very good evening. Physics class started. Yes, all students, please be ready. Yes, students. Now in our physics classes, basic maths going on. Already 2 classes completed basic mathematics. Yes, yesterday last now trigonometry class also over. Students, today one more now basic mathematics. But today class, some students now who coming from Olympiad schools and IIT orientation schools, yes, this chapter might be completed. That is differentiation. But students, for reminding students, it is a new topic. That's why from starting to ending, clearly listen, understand, and after the class, please solve the assignment. Yes, topic is today now differentiation. Differentiation, more important in our physics chapters. But of course, differentiation, very big chapter present in your main mathematics. But before your mathematics classes, only physics problems there. So that's why now, whatever may be the part related to differentiation required for our physics, so that I am going to explain today. Yes, concentrate on differentiation. Students, now before going to that exact differentiation, yes, what is that differentiation? So what's the significance of this mathematical tool, differentiation? Okay, just wait. Yes, so students, now here I am drawing one graph between y and x. So y versus x, one graph now I am drawing. So here function y equal to f of x. Any one function that may be straight line or may be a curve. So many curves we have. Logarithm curve is there, exponential curve is there, all trigonometric function curves there. Many curves there. So that's why y equal to f of x is one curve. That curve now may be like this. Any one curve. Now, so from our lower classes, we know slope of a curve. For example, students, y-axis versus x-axis. Slope of a curve. Yes, you all know slope of a curve or slope of a straight line. So first students, all students know straight line, but for the curve maybe or may not be. But straight line all students know. Yes, suppose here one straight line. This is y, it is x. Suppose it is one straight line. Slope of that straight line. Yes, it is for x1 value. Y value is a y1. For x2, y value suppose is a y2. So slope of that straight line, slope equal to change in y components divided by change in x components. So here y components, y2 minus y1 divided by x2 minus x1. Yes, all students know that slope of a straight line. Change in y coordinates divided by change in x coordinates. That is a straight line. That all we know. But now coming to the curve. Students, in case of a curve, that is y equal to f of x, different locations have different slopes. See now here slope different, here slope different, here slope different, here different, here different, here different, here different. So as point changes, slope of curve also changes. So that's why slope of curve, just like that now straight line equation, all parts are not possible. Because as just to point changing, yes, the slope also change. But in the previous case, straight line, any point if you take, slope is the same. That's why simple equation, change in y components divided by change in x components. Yes, now this type of, and also here in this curve, yes, here positive slope, positive, here zero slope. This is negative. This is negative. 0, positive, positive, positive. So like that in a curve, maybe 0 slope, maybe positive slope, maybe negative slope. So point to point slope changes. That slope, how to find out? Slope of a curve. So to find that, here one new mathematical operator is there. So that operation name is a differentiation. So this is dy divided by dx. It is nothing but slope of curve. Yes, slope of curve. Suppose you need x equal to 5 centimeter, you need the slope. First to calculate dy by dx, it is now how to read derivative of y with respect to x. So this is now differentiation operation here I am using. This operation will provide slope of a curve where you need at that point now it will provide. Suppose you need x equal to 5 centimeter. Once operation completed, you need to substitute x equal to 5. Then you will get at x equal to 5 slope. That means differentiation. Yes, but now this curves, slopes, differentiation, how our physics related. Students in the physics, yes, many parameters, best examples, suppose you take velocity. Velocity is nothing but slope of position versus time graph. Similarly, acceleration. Acceleration is slope of velocity versus time. So like this now, these are known parameters. That's why now here I mentioned. Many parameters there in our physics depending on slope of a curves. So that's why that all now differentiation where applicable, that all I am going to explain. This is just why differentiation required. What is the significance of differentiation only I explained up to now. Okay, students, please remember differentiation, that is derivative of y with respect to x, is nothing but slope of a curve y equal to f of x. At where you need x, that location we will find out the slope. Okay, now enter into main topic. Yes, students, now here curve y-axis and x-axis. First to y equal to 4, that equal to constant, suppose y equal to 4, that is one constant. So this graph now I am going to draw. Suppose it is the 4, y equal to 4 graph. This graph slope I need. Yes, all students know this is straight line slope how much? 0. Because y coordinates not changing at all. Change in y components by change in x components. Y components not changing. That means delta y is a 0. So that's why its slope is a 0. But students, now we know slope is nothing but derivative of y with respect to x. That means if y is a constant, its derivative is a 0. So that means students, here I am writing some functions. This is y and it is dy by dx. Y is our function, dy by dx is the slope of the function. That slope is nothing but our differentiation. Yes, here first we got now y equal to some constant c. What is the slope of a constant? 0. That means what is the derivative of constant? 0. So that is now first starting. Now students, now one more function here I am taking. Yes, constant completed another function. Here. Suppose one straight line. All students know straight line equations. Y equal to plus mx or minus mx or c plus mx or c minus mx minus c plus mx. So like that now many equations are there for the straight. So that to straight line, yes, general equation, suppose y equal to c plus mx. All students know y equal to c plus mx, y intercept positive, that is plus c, and slope is a m. So this is your straight line, y equal to c plus mx. But this straight line has the same single slope. Yes, here slope whatever may be, here, here, here. So that to slope is nothing but a. So not only now this now y equal to mx. The type of straight lines all now slope is a. That means coefficient of x is a straight line. That means now coefficient of x is slope of straight line is nothing but our difference. This is only one example. This is now y equal to, yes, some any constant into x. This is just only now first power of x involved. Maybe second power involved. Y equal, suppose x square, students, that is a parabola. Y equal to x square, 3x square, y equal to a plus bx square, ax plus bx square, many are. So yes, as x power increasing, that becomes a curve. So like that now here, one general common expression I am now giving, y equal to x to the power of n. Y equal to x to the power of n. N may be 1, 2, 3, 4, 5, even 0, even negative minus 1, minus 2, minus 3, minus 4. Not only just integers. Maybe 1 by 2, 1 by 3, 1 by 4, minus 1 by 5, minus 1 by 6, any number. So y equal to x to the power of n. Suppose function y equal to x to the power of n. What is the slope of that curve? So that is n into x to the power of n minus 1. Yes, so students, you need to remember this derivative of x to the power of n. Just you know only x to the power of 1 you know. That is not slope is n. But as power increasing, complicated curves will come. All complicated curves here we can't draw. Even drawn, we can't find the slope. So that's why students, x to the power of n no derivative, n into x to the power of n minus 1. And this complete now differentiation. How derivative of x to the power of n is n into x to the power of n minus 1. This is there in your mathematics true false. After limits continuity, then differentiation will come. Your mathematics will explain how derivative of x to the power of n is n into x to the power of n minus 1. But now before that, our problems there. That's why now I'm giving, yes, derivative of x to the power of n. This is the second function. Means another curve. Students, now I'm taking one more curve. Suppose if y equal to ln x. Yes, all know ln x means log x base e. Yes, y equal to ln x. So that ln x graph is different. For that graph, different locations, yes, we need the slope. So that slope is given by here our differentiation. Yes, students, remember ln x derivative 1 by x. Ln x derivative 1 by x. Next to Yes, another function here I am writing a to the power of x. Suppose a is one constant and x is now parameter. That means now variable x variable. Y equal to a to the power of x, suppose. That a to the power of x derivative we need. That derivative, remember, a to the power of x ln a. All students know ln a is nothing but log a base e. That is ln a. That is a to the power of x derivative. A to the power of x ln a. Log a base e. Yes, similar to, yes, here a is some number. Now coming to e to the power of x. All students know e value 2.718. So that e to the power of x exponential. That e to the power of x, e to the power of x into ln e. What is the ln e? Log e base e is nothing but a log e. But log e base e is 1 now. Yesterday logarithm topic I explained. So now e to the power of x derivative means slope of curve is nothing but again same curve. That is e to the power of x. Curve slope is again e to the power of x. Yes, students, here constant slope x to the power of n slope ln x a to the power of x e to the power of x. Now coming to some other functions, that is trigonometric functions. For example, y equal to sin x. Students, suppose y equal to sin x. In SSC, these graphs already came. Y equal to sin x, y equal to cos x, y equal to tan x. These all graphs already you know. Students, here suppose y equal to sin x. Y equal to sin x graph is this. So this graph slope is nothing but now derivative. See here slope different, here 0, this is positive, this is negative, negative, 0, again positive, positive, 0, negative, like that now, different locations, different now slope. That is slope, sin x slope is a cos x. Yes, derivative of sin x is a cos x. Means slope of sin x. Suppose now you need here this particular point slope you need. Yes, at this point derivative of sin x, later this x value you need to substitute derivative of sin x. Derivative of sin x is a cos. In that cos x you need to substitute. Similar to this, now suppose graph is cos x. Derivative is a minus sin x. Next to suppose tan x, secant square x, cot x, minus cosecant square x, secant x, secant x, tan x, cosecant x, minus cosecant x into cot x. Yes, students, this side all functions. That means required to draw a graph. That side all now their derivatives. Derivatives nothing but a slopes of different curves. But here derivative of constant to 0, derivative of x to the power of n into x to the power of n minus 1, derivative of ln x 1 by x, derivative of a to the power of x, a to the power of x ln a means log a base e to the power of x derivative e to the power of x, sin x derivative cos x derivative minus sin x, tan x derivative secant square x, cot x derivative minus cosecant square x, secant x derivative secant x tan x, and cosecant x minus cosecant x into cot x. Yes, so students, from here to here, these are now, yes, derivatives of some now familiar equations, familiar curves. But these all derivatives in your main mathematics class, your mathematics partner will explain, not only explain, a complete proof how that all derivatives. That is now again your mathematics differentiation chapter. Yes, nearly 1.5 months is there. In that you will know all this. Okay, but now related to our subject, that derivatives of some familiar functions we need. Yes, that all meanings and that equations are explained. You also please now remember those equations. That equations sufficient to solve our physics problems. Other than this, yes, many combinations are that now your mathematics are will explain. Yes, all students, please, physics students, remember from here to here. Derivative of constant 0 like that, up to the last derivative of cosecant x minus cosecant x cot x. Now only, just 1 minute time. You please now from here to here remember, because based on this now some complicated problems there. Yes, without now remembering that, here you can't solve. That's why please remember, just not more than 1 minute, remember that. Yes, so students all now remember that function and their derivatives. Derivative nothing but a slope. So now, after remembering all that now familiar equations, now some rules and regulations there in our differentiation. Yes, one by one that properties I will explain just to follow. Number one, first one. Derivative of some constant a into function y with respect to x. Here students, y is a function of x. That function, any function, yes, out of this now, any one function. But only one function, not combinations. Any one function out of that. But that is only the y. But what about this a? A is a constant. Whatever constant, maybe negative constant, positive constant, or maybe zero means nothing is. So that's why maybe positive or negative constant is a. So whenever this type of now differentiation problem is there, yes, a into derivative of y with respect to x. So this is now property number one. But how to use this? So 2 or 3 examples I will tell, then later you can solve on your own. Students, here x to the power of n derivative you know, n into x to the power of n minus 1. Suppose, first example, derivative of 16 x cube with respect to dx is there, suppose. 16 is a constant. So you can take now outside 16. 16 into derivative of x cube with respect to x. But students, derivative of x cube, already we know that formula, x to the power of n form. That's why 16 constant, just like a outside, derivative of x cube. Yes, use now that principle. 16 places 16 don't change. n is 3 here. So that's why 3 into x to the power of 3 minus 1, 2. Yes, now all students know. 16, 3, 48 x square is our final answer. So this is now one example to understand this. Like that now, you can use now any equation. For example, students, tan x. What is the derivative of tan x? Secant square x. Suppose same. What is the derivative of 16 tan x? 16 separate, tan x derivative secant square x. So like that, any constants there in that, take now separate and then write. But suppose students like this, 16 into tan x, okay, 16 secant square x. Suppose tan of 16x, that is no. That we can't write. That now another principle is there. Again, I will explain that. That's why students, this principle, that is property of differentiation. How to utilize that, you need to know. 16 into tan x, this property valid. But tan of 16x not valid. That is not another, I will explain that. That is another rule. So now, suppose here a to the power of x. A means some number, for example, 2 to the power of x. What is 2 to the power of x derivative? 2 to the power of x into ln 2 means ln 2 base b. Suppose 16 into 2 to the power of x is there. 16 into 2 to the power of x. Then you can write 16 outside. 16 into. Now 2 to the power of x derivative what? 2 to the power of x into ln. So that is the utilization. For example, here ln x is there. Ln x derivative 1 by x. 16 ln x, 16 separate. Ln x 1 by x. So that's why 16 by x is your answer. Suppose ln of 16x, this principle not valid. That is another principle. I will explain that. Yes, I hope all students know derivative of a, one constant into y with respect to x, a separate outside into dy by dx. One example. I hope all students understood this. Now I am moving to second principle. Okay, just you please take this now. Next to second principle. This is principle number 1. Now I am going to explain 2. Yes, rule number 2. Derivative of u plus or minus v. Otherwise, you take now first only plus or minus or plus or minus, no problem. With respect to x. Here, what are u comma v? U and v, just like that now y functions in x. U is one function in x, v also one function in x. Any function out of this, any function. So u comma v, these two are two functions in x. So that's why derivative of u plus or minus v with respect to x, because u and v already functions in x only. This one how to find? Derivative of u with respect to x plus or minus means here also plus or minus. Suppose plus is there plus, so minus is there minus, that's all. Yes, after that dv by dx. Derivative of u with respect to x. Suppose here plus is there plus, minus is there minus. Again derivative of v with respect to x. Means separate. Then later use this operator either. Suppose plus is there plus, minus is there minus. One example I am going to explain. Yes, derivative of any some function combinations I am using. Suppose students e to the power of x1 function, but I am taking 2 into e to the power of x plus sin x with respect to x. Yes, so students, this is now given function, its slope means derivative we need to find. Now it is valid. Second rule is valid here. Yes, plus means plus. Derivative of only first function first, next to second function second. But students here, in the first function, I am using now first rule number 1 also. So that's why 2 into derivative of e to the power of x, e to the power of x only, plus derivative of sin x, you know cos x already there. Students remember already. So sin x, derivative cos x. Yes, so students, derivative of this type of now combinations now easily we can find. One more example. Suppose derivative of root x plus cosecant to x, suppose. Any one example. This we need to suppose. Yes, so students, 4 root x one function, cos x another function, plus is the plus. Yes, now 4 root x. Root x we can write x to the power of 1 by 2. X to the power of 1 by 2. X to the power of 1 by 2, this equation is valid. X to the power of n. X to the power of n, n into x to the power of n minus 1. So n place 1 by 2, now I am going to substitute. Yes, students, first one, 4 root x, x to the power of 1 by 2, that is n value 1 by 2, 1 by 2, x to the power of 1 by 2 minus 1 means minus 1 by 2. X to the power of minus 1 by 2 is nothing but a 1 by root x. So now 1 by 2 root x. Yes, first function completed up to now. Now coming to second function. Students, cosecant x, our derivative we know minus cosecant x into cot x. But here plus is there, means plus plus only. But its derivative has a negative, that's why plus into minus, minus cosecant x into cot x. Yes, so students, now here I am using second rule, but in that second rule, here first rule also automatically used. That's why in this example, first rule we used and second rule also used. Yes, so this is now second one also completed, students. Now coming to third principle also. Third rule. Okay, 2 rules completed. Yes, you please all take now second rule and examples. Yes, now I am explaining rule number 3. Yes, rule number 3. Derivative of u divided by v with respect to x means here u and v, these two are again functions in the x. Again functions in the x. But u by v means 2 functions involved. One is in the numerator, another is in the denominator. Yes, it's now final answer denominator v square du by dx means derivative of numerator into denominator minus numerator into denominator derivative. Yes, so student, rule number 3, derivative of u by v with respect to x is derivative of only u, that is numerator, into denominator as it is, minus numerator into derivative of denominator divided by denominator square. Yes, for this also one example I am going to explain, just wait. Yes, so derivative of sin x, derivative of sin x divided by x to the power of 3 by 2 with respect to x. Students, numerator and the denominator. Same now rule number 3. Yes, first two. Denominator x to the power of 3 by 2 whole square means x cube. Now derivative of numerator. What is now sin x derivative? Already known. Cos x. Cos x into denominator as it is, x to the power of 3 by 2. Next to minus numerator as it is, sin x into denominator derivative. X to the power of 3 by 2 derivative means x to the power of n. X to the power of n, n place here 3 by 2. Don't write minus 3 by 2, no. Here x to the power of 3 by 2 itself x to the power of n. It is not now 1 by x to the power of 3 by, that's why here x to the power of minus 3 by 2, that is again u into v formula. But here I am using rule number 3, u by v. That's why x to the power of n means 3 by 2 only. So that's why 3 by 2 into x to the power of 3 by 2 minus 1 means 1 by 2. 1 by 2 means what, students? Root x. So sin x 3 root x by 2 divided by x cube is. So this is now by using rule number 3, differentiation complete. One example. Yes, for example here 5 sin x is there. Example 5 sin x by x to the power of 3 by 2, suppose 5. Here 5 sin x means rule number 1 also involved because 5 constant remaining as it is. Yes, so students, now rule number 3, carefully you need to know practice. So today some problems also I will give on this now. Yes, some problems you need to practice. U by v method is. It is now u by v. Yes, now constant 2 into function over, addition of 2 functions over, subtraction of one function from another function over, and division u by v. Next to students now multiplication. Suppose now u into v also. So that also an example I will tell, just wait. Yes, rule number 3, u by v. Rule number 2, either u plus v or u minus v. Now rule number 4. Okay, just wait. Yes, rule number 4, derivative of u into v with respect to x. Yes, again here u and v, 2 functions in terms of x. Yes, here du divided by dx means derivative of u with respect to x into v plus u into derivative of v with respect to x. Student, this is rule number 4. Here product is there. Yes, now an example. Derivative of any one example you can take. For example, 5 into tan x into e to the power of x, suppose. Students, here 5 is there, tan x is there, e to the power of x is there. But we know rule number 1. Any constant into function is there, constant outside, remaining function derivative. Same principle I am using, 5 outside. Now, du by dx means first function of derivative. Students, tan x derivative, secant square x. So, secant square x into v as it is, e to the power of x as it is, plus. Next to first function as it is, tan x. But the second function derivative here you need to write. E to the power of x derivative, e to the power of x only, right? That's why e to the power of x. Now bracket close. So this is now rule number 4. Yes, in this rule number 4, students, not only just uv, even third term w also might be there. Suppose derivative of u, v, w with respect to x, suppose. Yes, very simple. Derivative of u with respect to x into v into w. V into w means as it is v, as it is w, plus u into derivative of v with respect to x into w. U and w as it is, v derivative, plus u into v as it is, derivative of w with respect to x. Indirectly what I use now, u is nothing but one function, v into w combinedly one function I have taken. In that vw again uv method I used. So finally done. Yes, so students, here one more example. Derivative of root 2 3 to the power of x into cos x I am taking with respect to x. Any some combinations, because already we know all familiar equations of derivatives. Combinations I am taking. Yes, just like the previous root 2 constant, that's why take outside root 2. Yes, root 2 outside. Students, here first 3 to the power of x derivative we need. 3 to the power of x, nothing but a to the power of x means 3 to the power of x ln 3 means log 3 base e. 3 to the power of x ln 3 into again v is there means cos x as it is. Next to plus u means what? 3 to the power of x. Now derivative of cos x, obviously minus sin x. So students, here minus sin x. Now bracket close. So this is now derivative of u into v with respect to x. Yes, rule, and then how to apply this rule, some examples I explain. Yes, students, first all now ready-made equations and their derivatives. Yes, today you need to remember equations, their derivatives. And rule number 1, some constant into function. Rule number 2, either addition or subtraction of two functions. Rule number 3, division. Division of one function with respect to another means u by v. Division. Two functions to division. Rule number 4, product of two functions. Maybe 3 functions also. So these all rules now I used. Yes, some problems also explained. Only based on this. So today one assignment I will send you. Please now once our all classes over, one more time revise, and then later you please now do the practice, students. Yes, next to, as already we discussed, suppose 16 into tan x, derivative 16 into secant to square x, okay. But suppose tan of 16x. So this differentiation, how to do? This all now will come in part 2. That means tomorrow's class. Okay, students. Yes, physics class completed. Yes, another now mathematics are also there. Today you please revise again and later do the assignment ready for next class. Okay, thank you.